Alright, Ahmed. This is lm317 in this cool board. Let's try it out. I slapped in 1k resistor so we can both compare it with a standard resistor. Anyway, it's been powered by this power supply. I'm going to assume 11 volts, and this is DC by the way, so RMS it. And we can see that it's using 15 milliamps, tiny amount of current for this resistor. The output of this is 8 volts. We can assume it's 8 volts. You can twiddle this output with this screwdriver. Alright, so let's say we want to make it 5 volts, because I looked online and the L298 runs at 5 volts. Theoretically, I looked at it. The datasheet numbers do match up. 5 volts. If you output 5 volts of this, your motor controller can run off 5 volts because you're using L298. Let's say you are. Your photon uses 5 volts, and all the other sensors uses 5 volts. So let's just use 5 volts from the regulator. And there's no need for a linear regulator as well. So I'll stick this and I'll change the voltage. You can see it's pretty precise. Actually, it's not precise at all. Nah. And I'm gonna turn it really slowly, and then bam, it'll go down to the ground. There we go. You see, it way overshoots. Man, this is not easy to control. Ah, this is boring. I'm sure this is boring, but I'm not bored. Anyway, that's probably the close. Oh wow, this is pretty close. Anyway, incredible. Alright, at 1k, 5 volts at 1k. You can calculate the current from that. What's that? I is V over R, 5 over 1000. 5 over 1000, that's 0.005. We're getting 0.0019. So take away 5 from that. That L298, no sorry, yeah, this LM317 is using 14 milliamps just to keep itself going. I found a big resistor, right? Like a huge one. So big my multimeter won't even count up. It only goes up to 2 mega ohms. Anyway, this is 2.2 mega ohms. That means this will use a very, very, very small amount of current. And I'll replace this resistor with that one. And we'll see how it goes. Alright, we're back again. Well, while I was putting this one in, by accident I turned it on without the resistor. And nothing happened, so on its own it uses 12 milliamps. Not 14, 12. There must have been 2 milliamps flying somewhere. Anyway, this is cool as a cucumber. I can stick a nice warm one in, but yeah, and I can consume some current. But in reality, I think this is plenty for what we have. You know, you output 5 volts. Yeah, it's pretty cool. Because 5 volts is used everywhere in our machine. And with 12 milliamps current consumption, this isn't going to be our bottleneck at all. I'll try this with a tiny resistor and draw like, what's a maximum? I think we're going to draw a maximum of 200. Actually, the other team were driving a motor with 80 milliamps. Therefore, if I could draw 80 milliamps of this without a heatsink, then we should be fine. However, I'll probably bump it up to 200 milliamps to see if I actually need a heatsink, because we always need some overhead. Alright, let's try it out. 200 milliamps. I'll replace a resistor with the smallest one I could find, 33 ohms. Now, if you want a 250, as I said before, you're going to have a 25 ohm resistor. I didn't have that, I only have 33, I'm not Mr. Resistor. Anyway, with 33 ohms, you can get a maximum of 150 milliamps, which should be plenty of to run the motor, the photon, etc, and all the other goodies on our train. Alright, let's see how much it really is. 150 milliamps it should consume. Nope, doesn't work. Yeah, of course. I think the starting current was a bit higher. If you move this, it twiddles a lot. That means you've got a bad connection. 1 second. Alright, the resistance fixed, it's alright, 156 ohms, milliamps. Yeah, I measured the actual resistance of the resistor, it should be 151, and there's a couple here and there, you know, jogging around the board. Anyway, let's see how hot this is. It's just warm enough to slightly warm my finger, but it's nothing, seriously. It's nothing. You could run this all day, all night, it'll be fine. The resistor's hotter than it. Oh, the resistor's toasty. Yes, the resistor's hotter than it. Don't worry about it. You draw more current on that resistor, it gets unhappy. Wow, that you could start heating up tea and coffee with this one. Oh, I wouldn't mind having a shower with this. Oh, no, actually it burns. You don't want to shower with this heat. That's a tea and coffee kind of heat. Anyway, this one. Nah, nice. Now you need a heat sink. It's really, I'd say it's about 30 degrees. Probably your armpit. Yeah, something like that. Yeah, so you don't need a heat sink, you can draw a lot of current from this. 150, more than plenty for us. Man, that resistor's getting nice and warm. I like that. If I draw this, if I make this voltage go down, you'd get a hotter resistor. Because to get current, to increase the current, I equals V over R. No, other way around. If I increase the voltage, the resistor gets hotter. I won't burn it today. I'll keep it safe. Anyway, my multimeter fell out. Oh yeah, it fell out. There you go, 5 volts, it's real. Not fake. Anyway, see you, man.